In this video, we'll be building off synthetic division and the remainder theorem into the factor theorem. Now, in the last video, again, we spoke about the remainder theorem, and we kind of touched base on the concept of the factor theorem, but we didn't actually show any work with it. So in this case, we're going to go ahead and show, using synthetic division, that either this or this could be factors of this start polynomial. So what I'm going to do first is identify, again, the constant values that come from these. Now, keep in mind, if there's nothing in front of a power of x, then there's supposed to be a 1 there. So this is 1, 1, negative 21, negative 1, 20. Okay, I'm going to draw my line here. I'm going to go ahead and start my my little box. And over here, remembering that this is my divisor, x minus 2 equals to 0. If I solve that for x, x equals to 2, gives me what I'm going to divide by. So back over here in this box, I'm going to write down 2. Now, carry down the first value, 1. And again, you're not multiplying, you're just carrying down that first value. Then I'm going to multiply. 2 times 1 is 2. Put that here. Add 3. 2 times 3 is 6, put that here, add negative 15. Then I'm going to multiply that again as negative 30, negative 31, multiply here as negative 62, and providing me with a value ending up of 42. In this case, my remainder is not 0, so x minus 2 is not a factor. So I'm going to state that very clearly. X minus 2, not a factor of f of x. Okay, so again, the intent here is to determine whether or not these things are factors. So I'm going to look at this x plus 5 now, and I'm going to go ahead and do the same exact division with that, giving me 1, 1, negative 21, negative 1, and 20. Very carefully carrying down the first number, multiplying. Negative 5 times 1 is a negative 5. Negative 5 plus that is a negative 4. When I multiply negative 5 times negative 4, I get a positive 20, giving me a value of a negative 1 back, giving me a negative 5 times negative 1 is a positive 5. Here, adding, giving me a positive 4, multiplying negative 5 times 4, getting me a negative 20, and then adding, giving me a 0. So this provides me with a remainder of 0. So let's very clearly state what we have here. X plus 5 is a factor of f of x. More importantly, f of x happens to be equal to x plus 5 times, now this was up here originally x to the 4th. So if this was x to the 4th, this one is now x cubed. So I end up with 1x cubed minus 4x squared minus x plus 4. Again, the remainder being a separate entity. But again, it started with x to the 4th, and it loses 1 power every single time. You'll notice, looking at this thing right here, that we should be able to argue that if I was able to pull out this one factor, maybe this can factor further. Now, we can go ahead and consider what other possible options will divide this, but I'm going to look at this and notice that there's 4 terms and see that x cubed minus 4x squared. Using my skills from previous mathematical operations, I will simply use grouping to tear that apart, and over here factor out a negative 1, giving me x minus 4. So you'll notice very quickly that if I factor this utilizing, again, the skills that I've learned in previous sections, that this will factor further, which leads to us saying that if I can find at least one factor, then hopefully the rest of this can be done utilizing previous knowledge. And again, you'll notice the goal of these problems in synthetic and long division is to be able to take a polynomial and factor it apart into all of its possible factors. Again, you'll notice that there are 4 factors. There are 4 powers of the largest x, and these are each a different 0 to this polynomial.